Dear students, after having gone over all the reactions involved in the topic aldehydes, ketones and carboxylic acids, let's look into some interconversions. I have divided interconversions into two parts, right? So in part 1, the first interconversion is propanone to propene. So as I always say, write down the structures of the starting compound and the final compound first. Okay, so we have propanone, CH3COCH3 converted to propene, which is CH3CH double bond CH2. Alright, so number of carbon atoms are retained, but we have to convert ketone to a double bond. So if we focus on the double bond, you know that if you subject a secondary alcohol to dehydration, you get a double bond between these two carbon atoms. So from a ketone, we can get a secondary alcohol first. So we reduce ketone to give you CH3, CHOH, CH3. We can make use of lithium aluminium hydride. So ketone is reduced to a secondary alcohol, propan-2-ol. Now propan-2-ol or isopropyl alcohol, when subjected to dehydration using concentrated sulfuric acid and heat, a molecule of water is lost from propan-2-ol to give you propene. It's a very simple interconversion. The next one, benzoic acid to benzaldehyde. Now, so let's write down the structure of benzoic acid. So we have benzoic acid here to be converted to benzaldehyde. Now benzaldehyde CHO, benzaldehyde. Alright. Now benzoic acid can be, it looks as though benzoic acid can be reduced to benzaldehyde. But we know that there is a problem associated with the isolation of benzaldehyde because benzaldehyde is highly reactive. It is very difficult to directly convert benzoic acid to benzaldehyde. So it involves multiple steps. So first let's convert benzoic acid to. So how do we decide on what compound to convert benzoic acid to? Immediately try to recollect all the methods of preparation of aldehydes, right? Aliphatic and aromatic aldehydes, right? So one of the methods of preparation involves the Rosenmann's reduction, wherein you start with benzoyl chloride, which is a derivative of benzoic acid. So first let's convert the COOH to COCl. That can be easily done by using either thionyl chloride or PCl3 or PCl5. You've come across this in the chemical properties of carboxylic acid, wherein the OH is substituted by a halogen, namely chlorine. The reactions due to the breaking of the COH bond. Okay. Now, so this will give you benzoyl chloride. So now we have got benzoyl chloride. So try now recollect Rosenmann's reduction. Benzoyl chloride is subjected to reduction. It is a catalytic hydrogenation, right? So we have to make use of hydrogen gas in the presence of a catalyst. But if you use a catalyst like palladium or nickel, what happens is you will not get the benzaldehyde. As I told you, benzaldehyde is highly reactive. It gets further reduced to the primary alcohol, namely benzyl alcohol. So we have to inhibit the activity of the palladium catalyst by supporting it over barium sulfate, and a small amount of quinoline can be added. So in this manner, benzoyl chloride is reduced to benzaldehyde, a typical illustration of Rosenmann's reduction. Ethanol to but2-enal. Ethanol C2H5OH to but2-enal. CH3CH double bond CH CHO. Now but2-enal is an alpha beta unsaturated aldehyde. You have come across this compound in the context of the final product of aldol condensation reaction after heating, which means this conversion involves aldol condensation reaction. But for that we need an aldehyde with alpha hydrogen atoms. We have ethanol. So first step is to oxidize ethanol by using any oxidizing agent, say alkaline KMnO4, you will get ethanal, right? Now when ethanal is subjected to aldol condensation by condensing it with another molecule of ethanal, right, you will first get the aldol, which is CH3, CH, OH, CH2, CHO, right? You get the corresponding aldol. Now this aldol, when subjected to heating, a molecule of water is lost to give you butenal, a typical illustration of self-aldol condensation reaction. Okay? The next one, benzene to meta-nitroacetophenone. So first let's draw the structure of benzene to meta-nitroacetophenone. So we have acetophenone, CH3, COCH3, and at the meta position we have a nitro group. So we have to introduce the COCH3 and the NO2 group to the benzene ring. And those two groups have to be meta with respect to each other. So the nitro as well as the CH3CO group are both meta directing groups, right? So you can either nitrate benzene first, get nitrobenzene and then acetylate it. But we have a problem here. Nitro group is a highly electron withdrawing group, because of which the nitrobenzene does not undergo electrophilic substitution reaction very readily. So it's safer to first introduce the COCH3 group by Friedel-Crafts acylation. So we have CH3COCl or anhydride in the presence of anhydrous aluminium chloride in the dark. So what you first get is, you first get acetophenone, COCH3. Now this acetophenone, when subjected to nitration in the presence of concentrated nitric acid, sulfuric acid and heat, you will get meta-nitroacetophenone. Alright? Next, benzaldehyde to benzophenone. So, benzaldehyde to benzophenone, which is CO, another phenyl group, C6H5, not CH3, there is acetophenone, this is benzophenone. So what we can first do is, it is easy to introduce the C6H5CO group to a benzene ring. So our first task is to convert benzaldehyde to benzene. There is no direct conversion. So let's first oxidize benzaldehyde to benzoic acid. We can use mild oxidizing agents like concentrated nitric acid or toluenes or Fehling solution followed by hydrolysis. So by using mild oxidizing agents, right, you can convert benzaldehyde to benzoic acid. Right? Now you have to convert benzoic acid to benzene. How do you do that? You got to remove one carbon atom. You can subject benzoic acid to decarboxylation with soda lime. So heat benzoic acid with NaOH and calcium oxide, right? You will get Na2CO3 plus benzene. Now this benzene, on subjecting to reaction with benzoyl chloride, C6H5COCl, in the presence of anhydrous aluminium chloride, okay, you will get benzophenone, right? So these are the various steps involved in the conversion of benzaldehyde to benzophenone through a benzene. All right. Next, bromobenzene to 1-phenyl ethanol. So let's start with bromobenzene. bromine here to 1 phenyl ethanol. So, the phenyl group is at the first position. So, we have ethanol. So, CHOH, okay, and then we have CH3. First carbon atom. So, first carbon at the first position you have the phenyl group. So, 1 phenyl ethanol. Very evident that it is a secondary alcohol. So, you have bromobenzene. So, you can prepare a secondary alcohol using via a Grignard reagent. So, first task is to convert bromobenzene to phenyl magnesium bromide, the corresponding Grignard reagent in the presence of magnesium in the presence of ether. So, first you get MgBr, phenyl magnesium bromide. Now, let's see what the Grignard reagent should react with to give you a secondary alcohol. A Grignard reagent reacts with any other aldehyde other than methanol, right? And not, so how do we decide which aldehyde? You need 2 carbon atoms to be introduced to the benzene ring. So, obviously, we have to react phenyl magnesium bromide with ethanol, CH3CHO. So, first you get the adduct which is subjected to hydrolysis to give you the final product, namely 1 phenyl ethanol, the secondary alcohol. So, the conversion becomes very easy when you see the structure that you have to finally produce. So, looking at that you can decide the route. Alright. Next one. Benzaldehyde to 3-phenyl propan 1-ol. A very interesting reaction again. So, we have benzaldehyde CHO to 3-phenyl propan 1-ol. So, you have the 3 carbon atoms CH2. Here we have the benzene ring. Okay, there is a third carbon atom CH2CH2OH. This is 3-phenyl, 1, 2, 3, 3-phenyl propan 1-ol. It's a primary alcohol. So, how do we, now the thing is, we have to introduce, there is already 1 carbon atom on the benzene ring. We have to introduce 2 more carbon atoms, and that is, you can, so the only way to think about is a aldol condensation reaction. Let's see if aldol condensation reaction will work. Alright. So, you know that aldol condensation gives you an alpha beta unsaturated aldehyde, right? So, let's first see whether we can convert this to an alpha beta unsaturated aldehyde, which can be subsequently reduced to give you the corresponding alcohol. Let's see. So, first let's convert benzaldehyde to, let's subject benzaldehyde to cross aldol condensation reaction with which aldehyde? Already there is 1 carbon atom, totally we need 3 carbon atoms. So, think about an aldehyde with 2 carbon atoms. One more point to be kept in mind, benzaldehyde does not have an alpha hydrogen atom. So, the aldehyde which has to condense with this should contain an alpha hydrogen atom, and we need 2 carbon atoms. So, the obvious choice is ethanol in the presence of an alkali, and then we first get the aldol, which on heating you will get the corresponding alpha beta unsaturated aldehyde. So, let us draw the structure of the alpha beta unsaturated aldehyde. Benzene ring, CH, double bond CH, okay, double bond CH, 1, 2, 3, and then we have CHO. This is the final alpha beta unsaturated aldehyde that we get when you do cross aldol condensation of benzaldehyde with ethanol, right? Now, this we have introduced 3 carbon atoms. The only step required now is to convert aldehyde to the primary alcohol. So, we have got an aldehyde. Now, we have a double bond and an aldehyde, both of which can be easily reduced by using either lithium aluminum hydride or by catalytic hydrogenation, right? So, the double bond gets converted to single bond and the aldehyde gets converted to primary alcohol, right? Or you can even make use of lithium aluminum hydride. So, these are the various steps involved in the conversion of benzaldehyde to 3-phenyl propan 1-ol. Benzaldehyde again to alpha hydroxy phenyl acetic acid. Okay, a very interesting reaction again, conversion. So we have benzaldehyde to alpha hydroxy phenyl acetic acid. So let me first draw the structure of acetic acid. See, on this carbon atom we have an OH because it is alpha with respect to the functional group, and we also have a phenyl group. Okay, we also have a phenyl group, right? So this is the structure of alpha hydroxy phenyl acetic acid. So now you notice that there is an OH and a COOH on the on this carbon atom. So what can you think about? You can think about nucleophilic addition reaction of hydrogen cyanide with the aldehyde. So if you subject benzaldehyde to reaction with hydrogen cyanide in the presence of an alkali, what do you get? You get the corresponding cyanohydrin, which is CH, OH and CN, hydroxynitrile. The moment you see a nitrile group, what can you think about? Hydrolysis. When you subject this to hydrolysis with a dilute acid, will give you alpha hydroxy phenyl acetic acid. CN is converted to COOH. Benzoic acid to meta-nitrobenzyl alcohol. So we start with benzoic acid to meta-nitrobenzyl alcohol. So we have CH2OH, which is benzyl alcohol. At the meta position we have the nitro group, right? So first what we can do is, we can first nitrate, subject benzoic acid to nitration. Carboxylic acid is a meta-directing group. So we first subject benzoic acid to nitration using the nitrating mixture and heat. You will first get meta-nitrobenzoic acid, right? Now to convert COOH to CH2OH, it is definitely a primary alcohol, but problem is we have a nitro group. So if you subject this to reduction, the COOH gets reduced to CH2OH, NO2 will also get reduced to NH2. So we cannot use strong reducing agents. So first let's convert the COOH group to the COCl, okay, acid chloride, and that is done by reacting with SOCl2 or PCl3 or PCl5. So first we get COCl, this remains as NO2. Now this on reduction with a mild reducing agent like sodium borohydride will get reduced to the primary alcohol CH2OH. This is how you convert benzoic acid to meta-nitrobenzyl alcohol. Benzene to benzaldehyde. Now that interconversion is not difficult. Let's first write the structure of benzene to benzaldehyde. CHO. Right? We can convert benzene to toluene. So we can do alkylation, CH3Cl, CH3Br, in the presence of anhydrous aluminum chloride catalyst. You get toluene. Once you get toluene, you can subject toluene to ETARD reaction by reacting it with chromium chloride, CrO2Cl2, in the presence of carbon disulfide or carbon tetrachloride, and subjecting it to hydrolysis. You first get a chromium complex which is subjected to hydrolysis to finally give you benzaldehyde, ETARD reaction. So these are a few interconversions which you will be able to do well only if you have practiced all the reactions involved in aldehydes, ketones and carboxylic acids.